All right, we have to redo this tape. So let's start over again. Non-resident training course of Navy Electricity Electronic Training Series Module 14 Introduction to Microelectronics Navy Tribe the L14186. Approved distribution statement approved of the public release distribution unlimited. Microelectronics miniature miniature M2M repair program with high reliability soldering micro miniature repair procedures appendage glossary reference lifted index. Let's show. That's throughout this test of the course of the while even the technical manuals associated with the equipment that will be working on, you will find below the notation and some of the paragraphs notation will emphasize the safety hazards if the care must be taken to observe. Warning: any operating procedure practice or condition, etc., which may result in the injury to death of the not carefully observed or followed. Caution: operation procedure practice of the condition, etc., which may result in the damage of the equipment not carefully observed or followed. No, an operating procedure practice of the condition, etc., which is essentially emphasized, and then Chapter 1, Microelectronics. Learning of the learning of the at the beginning of the each of the top of the learning of the review information respect with the learning of the top of the competent of the check question of the base for the object of the successfully completing ECC, indicate they have then made the object of the learning the information learned object of the listed below the upon completion of the topic be able to outline the progress of the main for the history of microelectronics, distribution of the relation microelectronics, point, wiring with a high element density for the state of the art microelectronic limits to the advantage for the disadvantage point to point wiring high element density the state of the art electronic identify the printed circuit board diodes transistors for this type of the integrated circuit that describe the fabrication technique for the technique that determine the define the terminology of the microelectronic technology, including the following terms of the Navy SEAL command: microelectronic, microcircuit module, miniature electronic system, packaging level, the packaging 0 to 4, modular assembly, core board module, micro module, describe the typical packing level, the resembling of the microelectronic system, describe the technical interconnection of the microelectronic system, describe the environmental consideration of microelectronics. Introduction: Neets module 6 introduction electronic combination with the tube of the power supply. You've learned time to discover the thermonic combination with the open with the electronic technology progressive over the breaking with each of the off the normal more amazing discovery of the development of vacuum tube soon led to the lab of the simple radio with the become more complex over the communication modern system now allow it to communicate with other parts of the world via the satellite data not collected from space or probe without presence of the beam the microelectronic technology. Sophisticated control system allow the operator of the equipment remote control hazardous situations such as facilitating handling radioactive material, remotely piloting aircraft with the takeoff with the landing with the making sure with the interaction of the spacecraft and now with the Earth space flight with the computers end of the video game that would not possibly expect with the billions for the microelectronics. The most significant step of the modern electronics developed with the transistor Bell Laboratory in 1948 that was developed with the solid state electron as in fact was to the vacuum tube solid state to add with the transistor open the door to microelectronics is defined by the area of the technology associated applied with the realization electronic system most extremely small electronic parts of the or elements described in top of the tube with the need for the module 7 the introduction solid state device power supplies are termed the microelectronics normally associated with the integrated circuit with the microelectronics is often throughout the including the integrated circuits however the many other types of circuits also fall in the microelectronics category that discovered in greater detail under solid state of the later in the topic. During World War II, the need for the reduce the size of the power, weight, and the power of the microelectronic system more importantly, increase the size even though the system is more complex than the size of the weight, power requirements more rapidly increase finally reach to the point where they are unacceptable, especially with the aircraft, the infantry personnel with the carry the equipment to combat. These unacceptable factors have driven forth the development of smaller, lighter, more efficient electronic circuit components. Some of the requirements continue. The important factor of development of the new system, both military and commercial products, military electronic system, for example, continue to become the more highly developed capability, reliability, maintainability, increase the progress of development of military systems, setting advantage of the technology point to ever increase the technology knowledge of the microelectronics the Navy job. Alright, it is recording. Evolution of microelectronic. Earliest electronic circuits were rarely simple but composed with a few tubes to transform the resistor capacitors. Wiring with it was more learned by the designer to begin with. Increase the both sides of the complexity of the circuit with the components. The limitation were identifying the technology developed. Vacuum tube and equipment. The vacuum tubes were found with several to build with the problems involved with the light with those shows issued component with the traffic that were very quite heavy. It's unknown but they search for the traffic wave to 40 to 50 pounds. Additional the tube that generated a lot of the heat required warm time of the 1 to 2 minutes required the heavy power supply with 300 volts DC or more. Now, two of the same type, but they were exactly all alike with the output character for the designers were required to produce the character. The circle that could work, and any of the two with a particular type of the meant with additional components were often required with the tune. The circle the output of the character is square of the tube. The U of the figure 1-1 show with the typical vacuum tube shaft. The actual size of the transformer are approximately 4x4x3 inches. Capacitors are approximately 1x3 inches. Components of the figures are largely compared with the modern electronics. Show of the figure 1 show of the type of the vacuum tube. Circle with the circuit with the design either the complete system, the functional part of the large system, and then the complex system, such with the rare mini circle type of circuit. We need to come with the desired type of the multiple functions, stuff with the double diodes, dual triodes, tetras, and others to help considerably reduce the size of the control circle of the however the weight and the height with the power consumption continue the problems that plague the designers. Another major problem with the vacuum tube that was method of wiring component that referred to the point-to-point wiring figure 1, 2 for the excellent example of the point-to-point wiring. Not only did this wire look like a rat's nest, but often the unwanted interactions between components. For the example, that not all unusual and inductive capacitive effects between the wires, all point with the wires possibly posed a safety hazard for the troubleshooting were performed in the energy of the circuit that because of the exposed wiring testing point of the point-to-point wiring was usually repaired for the general purpose of equipment and common hand tools. 1-2 show the point-to-point wiring vacuum tube the circuit that provided the reliability under many conditions. So drawback larger size with heavy weight, significant power consumption that made them undesirable more situation. For example, the computer system, even the system extremely large and difficult to maintain. ENIAC of the complete electronic computer built in 1945 contained 18,000 tubes that often required a full day just to locate and replace the faulty tubes. Some applications we are still limited to the vacuum tube, the cathode ray tube within the radar over the television oscilloscope that do not yet have also have solid state counterparts. One of the concept of the Steve, the technician job with the monitor packaging instead of the build consists of the larger job of the build with the module with the block with each of the module perform the necessary function of the system of the modules to easily remove the replace with the troubleshooting the repair for instance if the faulty power supply could be exchanged with the good one for the keep it aside of the operation faulty unit that could be repaired with it while the out system for example the how of the tube the module concept with improve the efficiency of the electronics even with the advantage of the vacuum tube module still had fault with the tube the point to point wiring with solely in excessive size and weight with the power consumption remained a problem to be overcome. Vacuum tubes were based for the electronic technology for the many of the years, and some still with us that still emphasize the vacuum tube technology rapidly becoming the thing of the past. The emphasis of the technology and field of microelectronics. Solid state devices. Now, what it would give time for the review. The first few pages of the Neets module 7 the introduction. Solid state device and power supply with the professor. Solid state device. The transformers over the vacuum tube. Solid state device that took it rapidly. New type of the transistor diodes were created with the adaptive. The circuit with the reduction side of the weight with the power you with the compressed. The circuit the early weight of the most is 50 pounds with the reduced weight. Just a few ounces replacing faulty components such as the lighter solid state devices. Early solid state devices relied on point-to-point wiring, which caused many of the disadvantages mentioned earlier. Metal chassis similar to the type of the tubes with the required with the physical support with the component of the solid state chassis was considerably smaller. With lighter, older tube chassis. Still a greater improvement with the component of the mounting methods may be yet to become. On the most significant development circuit packing has been the printed circuit board PCB with the shown in the figure 1-3. The printed circuit board is usually epoxy board with circuit leaf that have been added with the photo etching process similar to the photograph of the copper clad boards exposed with the counter light with the desired circuit of the pattern the edge of the remove of the unwanted copper of the process leave with the copper strip of the land to the connect with the components and the grand general printed circuit boards unlimited with both heavy and metal chassis point-to-point wiring. Although printed circuit boards represent the major improvement of the tube technology, they are not walled without, for example, the number of the components on each are limited inside of the shape of the component. Also, the vacuum tubes are easily removed with the test and replaced from the printed circuit board's components are soldered into place and are not easily removed. Normally, the printed circuit board contains a simple single circuit assembly with the system. All printed circuit boards within the system are routinely interconnected with the cable harnessing grouping wire with the ribbons, but they may be confronted with the problems with the faulty harnessing connection with the effective system reliability. Such problems are often caused with the wire airings because of the large number of the wires and part of the damage to the wires and connectors. Another mounting of that for that has been with the creep of the number of the components that give it display for the cordwood model with the figure 1-4C for the components that play for the particular with the end plate for the components are packed with the various close with together packed with the stack with like a cordwood it for firewalls play. The end plates for usually small printed circuit board must maybe the insulated solid white wire with shown figures shown the figure cardboard modules maybe or may not be encapsulated totally embedded in solid material, but either in case of the difficult to repair. Show the 1/4 of the cardboard board module. Or your integrated circuits. Many advertisement electronic equipment refer to the integrated circuit solid state device now, meaning the term solid state by the integrated circuit. They accept the name used in integrated circuit that consists of the elements inseparably associated formed one with one signal substrate with the bounding circuit. The other words, circuit components. All of the interconnections are formed as a unit. Will be concerned with the three types of the integrated circuit: the monolithic, film, and hybrid. Monolithic integrated with the form completely within the semiconductor substrate, but they integrated commonly referred to as silicone chips. A film integrated circuit with broken down with the two categories: thin film, and thick film. With the film components made with the either conductive or non-conductive material of the deposit with the desired position for the ceramic glass substrate. But the films are only to be with the passive circuit components such that the resistor, capacitor, transistor, diodes are added to the substrate. The complete circuit difference between the thin and thick film with the discussed later in the topic. Hybrid integrated circuit to combine two or more integrated circuit type to combine one more integrated circuit type with the discrete. The separate with the components of Figure 1.5. The example of the hybrid integrated circuit consists of the silicon chip within film circuitry with the two small circuit squares. The chips are irregular shaded with gray in our film components. 1.5 show the hybrid integrated circuit that save the art monolithic electronics. Microelectronic technologies today include the thin and thick film, hybrid integrated circuit with the combination for the circuits of the circuit apply with the digital switching linear analog circuit to become the currently training with the party the number of the circuit with the signal chip that you may look with the further increase the packaging densing electronics with at the same time you make circuit the projection side of the weight with the number of the connection with the individual system improvements reliability system capability is also to be expected thus in even existing capabilities for improving the new area of the microelectronic being and explore with the particular use of the technology will leave the impossible have with the demand for the increasing effect of the electronics system continues to improve the continuum the made with the state of the art with the microelectronics to meet the demand. Large scale integration ISIs, LSIs, or very large scale VLSIs are the result of the improvements of microelectronic production technology. Figure 1.6 representative of the large scale integration as was shown figure the substrate water wafer silicone semiconductor insulator material is used instead of the one that has been separated with the individual circuit. The large scale integration very large size and scale integration variety of circuits have been implemented at wafer size resulting further size weight reduction in IC integrated circuit with the modern computers such as the home computers may contain the entire memory processing circuit in a single substrate. Or 1/6 of the large-scale integration device. Large-scale integration that generally applied with the integrated circuit consisting of from 1,000 to 2,000 logic gate to 1,000 to 64,000 bits of the memory logic gate, but should be recalled with the Neets. Multiple 13 introduced numbers over the Boolean logic circuit in electronic switching network consisting combination transistor diodes resistor. Very large-scale integration is usually integrated with a combination over 2,000 logic gates of the greater than 64,000 bits of the memory. Fabrication microelectronic device. The purpose of the section of the give you a simplified overview of the manufacture of microelectronic device. The process of the form more complex that will desire to describe here. Still, you will be able to microelectronics is not magic, highly developed technology. Develop the microelectronic device. Begin with the domain with the interest. The result of this research with the device. The need with the interest. You must be simple diode network with a complex circuit with a thousand components. No matter how complex the device, the basic set of the production similar. Each type of the device require the circuit design component with arrangement, preparation of the substrate with the device and proper materials on the substrate. First consideration is developed with the new device determined with the device with accomplished is decided the engineers can design the device during the design phase of the engineers will determine the number of the type of the component with the interconnections needed to complete with the planned circuit. Alright, your component arrangement. Planning of the component arrangement of the microelectronic device very critical phase of the production of the camera input must be taken with the ensure the most efficient space available of a simple device that can be accomplished by hand. In other words, the engineers can prepare the drawings component with the placement. However, the computer that use the prior layout of the complex device. The computer is able to character of the component that can be provided with the printout with the most efficient component placement. Component placement is therefore transferred to extremely large drawings. During this step, the care is made to take the pattern for this with they appear with the substrate figure 1/7 that show with a fairly simple integrated circuit mass pattern. The end pattern which prepared for the production would be drawn with a several hundred times size shown in the photograph. The photo would be reduced in size until the actual desired size. At this time, the pattern would be used to provide several hundred patterns would be used. The one substrate. The figure 1/8 illustrates how the pattern would be distributed to act as a wafer mask for manufacturing. Actual size mask integrated circuit pattern. Your circuit mask, your wafer mask. Wafer mask is just a device used with the deposit material with the substrate. Allow the material with the deposit with a certain area of the button, not others, but changing the pattern with the mask with the chain with the component with the arrangement of the circuit. Several different methods may be used produced with a simple microelectronic device. Used with the proper circuit with the conductor, semiconductor, insulated material may be applied with the substrate with the transistor, resistor, capacitors, interconnector, ladder. Interconnecting lead. Substrate with the production. As mentioned earlier, with the top of the microelectronic device are produced with the substrate, but the substrate will be either with the insulated semiconductor material, depending on the type of the device, film, of the hybrid integrated circuit that normally construct with the glass ceramic substrate, with the ceramic used with the preferred material because of the durability substrate, used with the monolithic integrated circuit that are semiconductor material, usually silicon, into the type of the integrated circuit with the substrate can be actively part of the integrated circuit. Glass ceramic substrate, there you provide support with the component semiconductor substrate with the produce with the artificial growing of the cylindrical crystal with the pure silicon germanium. Crystals are grown with a seed crystal with the flow and the molten material by slowly lifting and the cooling of the material repeatedly. The processing takes place up under rigidly controlled atmospheric temperature conditions. Figure 19. So it's a typical crystal furnace with the seed of the crystal with the lower until they come into contact with the molten material silicone in the cave of the rotate with the raised very slow with the seed of the crystal with the lower temperature with the molten material that you with the contact with the solid seed with the solidifieds of the again around the seed with the seed lifted with the process continuing with the growing of the crystal. Desired length with a typical crystal is shown with the 2 inch with the diameter, 10 to 12 inches along with the larger diameter control that can be grown with the need of the industry, the purity of the material is strictly controlled with the maintain specific semiconductor properties depending on the need of the negative or positive impurities are up to average produce the desired characteristics of the other method of growing crystals exist between, but basic concept of the crystal production is the same. All right, so you raise, rotate seed crystal, crown crystals, molten silicone, heating coil. The cylinder semiconductor material is grown with the life of the thickness of the 10 hundredths to 20 hundredths of an inch, and the first step of the preparation shown figure 110 with the wafer to the ground with the polish to remove any of the irregularities to provide the smoothest strip of the possible, although the both side of the polish only with the solid on the side of the receiver the component with the perfect finish. Show the silicone crystal wafer to the thickness of the 10,000 200ths of an inch, 100 to 200 thousandths of an inch silicone crystal with the diameter 1 inch to 2 inches, length of 10 to 12 inches. Show fabrication of the integrated circuit devices. Fabrication of the monolithic integrated circuit with the more complex aspect of the microelectronics that we discovered. Therefore, the introduction module will try to simplify the process as much possible, even though the discussion very basically intent but still with increase the appreciation and progress in the microelectronics. Should the result of the discussion come to relive the advance of the manufacturing technology are rapidly with saying the rest for these extremely difficult. Monolithic fabrication. The two types of monolithic fabrication will discover the diffusion method and the epitaxial method. The diffusion method, the diffusion process begins with a highly polished silicone wafer placed in the oven. The oven contains the concentration impurity made with the impurity of the yield with the desired electrical character of the concentration of the impurity added and diffused in the wafer. The control of the controlling temperature of the oven and time with the silicone wafer is allowed to remain in the oven is called doping. The wafer has been uniform doped. The fabrication semiconductor device began with the several hundred circuits that is produced with the simultaneous wafer. 1/11 of the wafer diffusion oven. In the wafer, the atmosphere of the negative and positive impurities heater in the oven. The step in the fabrication process described here with the illustration figure 112 will produce the non-negative positive negative polylinear diffused transistor, but a slight variation. Typical may be also be applied to the production complete circle. They include the diodes, resistor, capacitor steps that are performed in the following order. Oxide coating starting material negative type. 2. Oxide remove the base diffusion. 3. Base diffusion oxide during base diffusion. Positive type boron diffusion. Oxide removed from the emitter diffusion. 5. Emitter diffusion antioxide formation. 6. Oxide removed the emitter and base contact. 7. Aluminum depositing alloying to form leads. All right, 1. An oxide coating thermally grown over the negative type of the silicone starting the material by means of photolithographic process of the window with it open through the oxide layer. This is done through the use of the mass discussed earlier. The base of the transistor form of the place of the wafer the diffusion furnace containing the positive type of impurity such as the boron control of the temperature of the oven and the length of the time. The wafer is often if you control the amount of the boron diffused the window of the boron will actually speed slightly beyond the winding opening of the next oxide layer is allowed from the over area with exposed of the window. For a new layer of the different mass, much smaller than the first opening in the new oxide. The negative type of the impurity such as the phosphorus is diffused the new window with the form of the emitter portion of the transistor. Again, with the diffused material will spread lighter beyond with the window opening. So another oxide layer is allowed with the form over the window by the means of precision masking technique of very small windows of about 5,000th of an inch in the diameter, open both in the base of the emitter region, but the transistor to provide access to electronic curve with aluminum deposited in the window allowed for the lead of the transistor of the integrated circuit. The note that the positive negative junctions are covered throughout the fabrication process of the oxide layer through the preventive of the contamination. The epitaxial method. The epitaxial process involved with the depositing of the very thin layer of the subsilicon for the form of the ununiform doped crystalline reach of the expectile layer with the substrate with the components that produce available using appropriate material for the expedite layers in the same way with the planar diffusion method. The planar diffusion expedite techniques are combined with the component with the character to improve the become the uniform doping of the expedite layer. The cross-section of the typical planar epitaxial transistor is shown figure 113. Note that the components do not penetrate with the substrate they did in the planar diffused transistor. So the gray is the darker gray is the oxide, and white is the lead contacts. You have the silicone substrate collector, emitter, base emitter, and the epitaxial layer, the collector contact, emitter contact. Alright, isolation. Because of the closeness of the component with the integrated circuit, the isolation for each of the other components is a very important factor. The isolation preventing unwanted interaction leak between the component with the leak could cause the improper operation of the circuit. The technique that were developed and improved the isolation the most improperly the use of the silicon oxide, which is excellent insulator. Some of the manufacturers experiment with the signal crystalline silicone growth and insulating the substrate with the other property UVD. Or also for too complex to get in there into there with the progressing isolation techniques, the reliability and efficiency of the integrated circuit will increase rapidly. The film term where you describe the technique of depositing passive the circuit elements on the illustrating substrate with the clothing of the thickness of the 1/10,000th of the inch of the centimeter maybe method of film depositing existing but two most widely used the vacuum evaporation cathode sputtering. Vacuum evaporation method that uses depositing many types of the material of the highly evacuated chamber within which the material is heated. The electricity shown in figure 114 material the radiated the straight line with all the directions from the source of the shade shadowed by any object in the past. Vacuum chamber the mass wafer the wafer support material to be evaporated to support the heater vacuum pump. The wafer there's a property mass figure 115 plate with above with some distance for the material being evaporated. The process complete with the vacuum is released. The vacuum the mask are removed from the wafer. The process of leaving the film thin and uniform film with the depositing material on all parts of the wafer to expose the open position of the mask. The process also uses the deposit the interconnections leads between the components of the integrated circuit. Shift the mask and slot of the interconnection wafer of the active elements diffused at 115 evaporation mask. Evaporation technique is most suitable to deposit for the hybrid reactive material such as the aluminum. The difficult work in the air with the method of cleaning the lava the better contact with between the layer of the deposit of the material of the surface of the but it has been deposited addition between because of the evaporation between and being with the travel in a straight line with the very precise materials may be produced. Or cathode sputting. A typical cathode sputting system illustrated figure 116 phosphate is performed with a vacuum potential of 2 to 5 kilovolts applied between the anode of the cathode of source of the material produced the glowing discharge of the space between the electrodes of the ray with the atoms sputtered off of the source of the material depending on the number of the ions and struck the number of the atoms they ejected each of the bombardment. The ejected atoms deposited uniformly over the object with the chamber. The sputtering cycle is complete with the vacuum in the chamber. The relief of the wave is removed. The mask are removed from the wave, relief and deposit the form of the passive elements of the circuit shown in figure 117. The vacuum chamber, the cathode tube of the cathode wafer with the mask and the ground anode, the heater, and the potential negative and positive reactive gases. Cathode sputtering system. Resistive elements, mask cutouts, capacitor, mask, glass, ceramic substrate. The finely polished glass ceramic with the oxide silicone has been used for the substrate of the material for the film with the number of the material that include the nichronium, the compound silicone oxide with the chromium, cement, titanium has been used for this thin film. Resistant nichronium must be widely used for the process for producing thin film capacitors involved with the disposition of the bottom electrode. Dielectrical, finally, atop of the electrode, the most common use of the dielectrical materials are silicon monoxide, silicon dioxide, thin film. Our thick films are produced with a screen pad with the conducting insulating material with the ceramic substrate with the film with the material with the thickness at least 10 times greater than the meaning of the feed pad of the electron material with approximately 1/10,000 with a centimeter of the technique used to produce the last elements such as resistors and capacitors. Procedure 1. Proceed with the fabricating thick film with the series with the sensible the skull with the screen with the screens are played with the substrate with the appropriate with the conducting insulating the material wiped the crop with the screen. The other one, once the conducting insulating material has been applied with the screen, they remove the formatting of the fire of the temperature of the above 600 degrees Celsius. The process forms a lava the permanent bonding with the insulating substrate with the tenlay. The exam of the character of the film, the gradient control with the firing temperature, length of the firing time. Resistant film, thick film with the various that can be held with a tolerance of positive negative 10%. The closer the tolerance obtained with the trimming each of the resistor after the fabrication. However, the different cement formulations use the produce the wide range of the component parameters. For example, the material use the 10 ohm per square resistor is quite different than use the 100 kilo per square resistor. Capacitors, resistor capacitor network. The capacitors are formed by the sequence of the screen with the firings of the capacitors, shape of the case with the consistent of the bottom plate with the interconnection with the dielectrical top plate with the resistor capacitor network. The next step would be to deposit the resistor material with the screen. Follow step with the screening and firing with the glass enclosure seal the unit. Hybrid microelectronics. Hybrid microelectronics is one of the fabricated combining two more circuit type of the circuit with the semiconductor circuit with the combination of one or more of the circuit discrete with the cement with the more parameter advantage. The hybrid microcircuits with the design flexibility. Hybrid microcircuits is made designed to provide the wide use of specialized application, low volume, high frequency circuit with the several elements. Circuit are available. The hybrid application these include discrete with compound electrical, mechanical, compatible integrated circuit. Some components that may be used to perform function with the summer implemented the integrated circuit they have been handled the test assembled with essential technology low tools and hybrid integrated circuits should be in large chips as shown in figure 118. 118 chip with a hybrid ingredient shown in large chip. Complete circuits are available in the form of the unencapsulated chip, the unencapsulated integrated device. These chips they usually indicate those solved with the part of the manufacturer's regular production line. They must be properly packaged to connect with either the higher quality finer assembly to be obtained. These circuits are usually sealed with the package to protect them with the mechanical and environmental stress. 1 mil or 1,000th of an inch good wire lead to connect with the appropriate pin with the package to allow the external connections. Alright, packaging techniques. On the integrated circuit that has been retrieved with the housing with the particular form of the damage could result with the moisture, dirt, and heat, the radiation of the product of the housing project with the device and the aid the handling with the connection into the system of the integrated circuit. The three most common type of the package of the modified the transistor outline package, the flat pack, and dual inline pack. The transistor outline pack with the transistor outline pack. The transistor outline pack was developed early with the experience with the transistor reliable pack of the only require the included number of leads to make the integrated circuit with the leads number of the 2 and 12. Then with the beginning with the 10 most to come, the integrated circuit application figure 119 explode with the view of the transistor outline 5 package of the integrated circuit that has been checked with the heater mounting wire with the attached for the integrated circuit with the leads. The cover provides the necessary protection for the device in figure 120 with the enlarged photo of the actual of the transistor outline with the cover to remove that you can easily set with the handling with the integrated circuit without packaging with it would be difficult with the technician. Or the cover of the wire bonds, bonding, island, monolithic die, solder. Also the header, the Kovar outlet plated gold cyanidine performing leads, and shows a dime and the transistor outline 5 package. Modified transistor outline 5 package can be either plugged within the view A and bed with the view B with the board with the emitting method is preferred. The package plugged with the med with the interconnection area with the package leave with the sufficient clearance with the both sides of the board. The plug method does not provide a sufficient clearance between the pad with the route and the additional circle with the package with the embed with the sufficient place exists between the pad with the increase the design of the interconnection pad with the shown with the review B with additional conductors. A the plug in mounting 270 thousandths of an inch. And transistor outline 5 mounting, plugging, mounting. 500 thousandths of an inch embedded cam LEDs plugged in. Or your flat pack. Many types of the integrated flat and circular flat packs are being produced with the various size of the material. These packages are available in square, rectangular, oval, circular configuration, 10 to 16 external leaves. They may be made in metal, ceramic, epoxy, glass, combination of the material. The only ceramic flat pack we discussed here. The representative of all the flat packs will respect the general package requirements. See Figure 122. Or a ceramic covered glass solder, the monolithic die, the bonding pad, gold reform, aluminum wire bonding wires, metal slurry, kind of ceramic mounting base, aluminum bonding wire leads, gold plated Kovar external leads. After the external leads are sealed with the bonding of the base for the rectangular area with the inside of the bottom of the base with the tree with the metal slurry that provide the surface of the suitable with the bonding with the monolithic die with the base of the lead, the metal of the area with the bottom of the package plate with the gold dies, then attached with the gold silicone bonding. The die bonding step of this valve with the bonding of the gold with aluminum wire between the bonding island with the integrated circuit with the inner position for the package lead with the next to the gold sliding perform frame with the place on the top of the mounting base on surface with the ceramic cover the pyro ceram glass and cover the plate at the top of the mounting bath. The entire assembly is placed only the within 450 degrees Celsius. Cover the glass side of the pyro ceram view for the seal cover the mounting base of the ceramic flat pack. The shown figure 123 has opened and so that you can see the chipping in the bottom of the wires. Typical flat pack. Okay, dual inline package. The dual inline package was designed primarily to overcome the difficulties associated with the handling and inserting the package for the mounting board. The dual inline package is easily inserted with a hand or a machine that requires no spreading of the space for the insulated leading form tool for the hill and tool with the soldering irons can be used to fill surface of the device. The plastic dual inline package are fine wide with the use of the commercial application number of the military surface incorporating ceramic dual inline package. Progressive stage is assembled in ceramic dual inline package with their shown figure 124 view A through E with the integrated circle with the die with a sandwich between the two ceramic elements shown view A with the element of the left view A. The bottom half of the sandwich would hold the integrated circle with the die with the ceramic section with the right half top of the sandwich large view large well view with the B with the first integrated circuit die with the mechanical structure during sealing operation of each of the ceramic elements clearing that code with the glass below melting temperature subsequent to joining and securing sealing view B show with the Kovar lead frame stamped and bent into the final shape of the excessive material intended to preserve the pinning alignment of the holes at each end of the key jigging view the final sealing operation lower half of the ceramic package insert with the lead frame shown with view C with the die with the bottom with the wheel. These are attached to the top ceramic element the bottom of the element shown view D. The excessive material removed with the pack of the view E is the final product. A, B, C, D, E, ceramic dual dual inline package are processed individual, while dual inline packages are processed the quantities of two or more in a chain fashion. The process of the packaging is solved with pour with plastic package, also with the cover lead frame with the leaf with the bite with the package with the complete with the both not bowl for the molded plastic is used with the encapsulated the integrated circuit with the die with no void will be exist between the cover and the divide and cave of the ceramic packaging. Present package ceramic dual inline package are most common. The two package type of the found Navy the Microelectronic figure 125 to the dual inline package, which has been open. The dime and show of the dual inline package. And the basic development of the inline package. Basic development in packaging. The considerable effort devoted to eliminating fine wires where connecting the integrated circuit with the covar, leave the emission for the village wire with the reduce of the cover, the integrated circuit with the eliminating the cover, the associated with the bonding, profit the further emission of the wires, improve the reliability, eliminating the common cover, the circuit failure. A promising package is a technique for the face-down flip chip of the mounting, the method of which the conduct of the patterns evaporate with the inside of the package before the die of the tab of the patterns connect with the external leaf of the bonding pad with the inside of the strip of the die of the pads are then bounded to the appropriate pedestal of the package corresponding with those of the bonding pads on the die figure 126. Inverted die of the bonding pads on the strip of the package pedestal of the leads and aluminum oxide substrate of the deposit conductors figure 126 flip chip package. Beam lead technique is a process to develop the batch, fabricate many at once. The semiconductor ceramic elements integrated with electrodes extend beyond the edge of the wafers shown figure 127 the type of the strip of the input with the no electrical difficulty parasitic capacitation of the the hundreds of the microfarad per rad per lead, the equivalent of the wire bound brass chip that assembled an additional electrode made to be tampered to allow with the lower inductance and impedance matching better heating conduct with the beam lead technique with the accomplished does not have the disadvantage chip the brazing wire but bonding feasible ability of the technique have been demonstrated the variable digital liner thin film circuit the beam lead oxide negative positive negative beam lead technique. Another advantage of the package with increasingly dual inline packages. The general dual inline package have been from 4 to 16 pins because of the large scale in scale, very large scale manufacturing production, dual inline packaging with up to 64 buttons. Although so they increase the considerable advantage of the dual inline packaging. Retain dual inline packaging is normally designed to have a particular specification set by the user. Alright, equivalent circuits. The beginning with the topic with the more application microelectronics. You to understand these applications cover all the area of the modern electronic circuit technique of the microelectronic circuit integrated circuit that produce the can be used with many of the varying circuit applications to justify the need of the modern technology section of the some of the applications will use some of the equivalent circuit comparison with the discrete component of the integrated circuits. The JK flip-flop size of the integrated circuit side of the integrated circuit that can be produced with the combined element of the complete electronic circuit that can be done with a single chip silicone, single chip of silicone combination of the film with components, the importance of the new production method of the evaluation microelectronic demonstration with the pairing of the conventional JK flip-flop circuit incorporating solid-state device, discrete device, the same type of the circuit employing with the integrated circuit. The JK flip-flop circuit is primarily in the computers. You should recall that Neets Module 13 introductory number system bowling algebra logical circuit with the basic flip-flop to decide the device having the two stable state with the two internal input terminals for the type of the input signals and signals each of the widths correspond with one of the two states. The flip-flop remains the one state with the until the chain, but then stay with the other application input voltage pulse. So the JK flip-flop differs with the basic flip-flop because of the third input with the terminal clock pulse with the trigger they usually apply with the input the ensure proper timing. The circuit the input signal must occur at the same time with the clock pulse chain with the side with the flip-flop. The conventional JK flip-flop circuit the figure 128 requires approximately 40 discrete components, 200 connections, 300 processing of operations with each of the 300 operations seal the connections representing the possible source of failure if the circuit elements of the circuits are encrypted with one chip of the silicon, the number of the connections drop to approximately 14. The basic of all the circuit elements interconnected including some of the package of about 300 processing operations reduced to approximately 30. Figure 129 represents the size of comparison of the discrete JK circuit with the integrated circuit is the same type. Alright, so if the schematic diagram with the JK flip-flop, input with the set and clear input and the ground and timing. Alright, discharge circuit, integrated circuit, the JK flip-flop, discrete component with the integrated circuit. The integrated packaging lead to identification numbering. When you're looking at the integrated circuit packaging, you should know that the integrated circuit cannot be connected incorrectly into the circuit. The proper replacement of the component would likely result in the damage of the equipment. For the reason the integrated circuit, the reference bond line with the component of the placement of the dual inline pack with the both the plastic of the ceramic, the flat pack with the notch dot impression of the package with the view for the top of the pin, the one with the first pin with the counterclockwise direction, neck with the reference bar with the pin one may be also marked directly with a hole notch and tab on it, and scale of the pin one with the counter reference for the pack of the review on top of the other pin with the number of the consecutively counterclockwise direction pin 1 shown in figure 130 view A and B. All right, one show of the pins 1 through 14. Top view, dual inline package, dual inline package, flat pack, leading number, dual inline package. Top view tab 1 through 14, flat pack, dual inline package, flat pack, leading number, the flat pack. The two transistor outline 5 that can be either tab the reference mark with the number, leave them. You must remove the transistor outline with the 5 that can be from the bottom of the pin. One be the first pin with the counterclockwise direction. The tab of the other pins will be numbered consecutively clockwise direction of the pin, shown in figure 131. 131 show the leading number of the transistor outline 5. Bottom view 1 through 8, 1 through 10 tab identification. Integrated circuit identification. As mentioned earlier, integrated circuit design manufactured with 100 of the different with the U, with the logic circuit, with the clock circuit, with the amplifier, television, and transistor, receive the musical instrument, the view of these applicate for the schematic diagram. The integrated circuit usually represented with one with the schematic base symbol shown in figure 132, with the integrated circuit identified with the corner U with the number of the print on the near with the symbol of the series with the number of the letters and the sample of the K of the device for the K should be can be used along with the dash U, the shown with the dash U with the figure 133 circuit design maintenance profile down dash U, the provided the manufacturer provided the schematic diagram to describe the type of the device, electrical characteristics, typical application of the dash sheet may also show the pin configuration with the pin, all pins labeled the pin configuration and not shown, but they may be the schematic diagram shown with the pin function with the sum of the data is given them both in pin configuration schematic diagram shown in figure 134. The figure illustrates the manufacturer's data sheet with all the pin functions shown. Alright, some schematic for the integrated circuits and an OR gate. You have your amplifier, your what I don't know what that would be, but all right, and then your operational amplifier, voltage comparator, low drift, sample, hold, low offset with the temperature drifts. You have the metal cam package, flat package, dual inline package, schematic diagrams, typical flat for FET operational integrated bias complete circuit completion. Features and description, application, pin output, and functional schematic. Be ground, you know. All right, microelectronic system design concepts. You should understand the terminology microelectronics to become the effect of the knowledge of the technician should be familiar with the packaging concept of the maintenance of the standpoint, but they able to recognize the different type of assemblies. You should also know the electrical environmental effect of the effect of the microelectronics. The next section of the topic we will define and discuss each of the areas. Terminology, a special electronic field of the microelectronic definition of the clarify the communication done and everyone involved with the microelectronic works to have the same knowledge of the field. You imagine how much trouble you would have to remember the 10 or more different name of the definition for the resistors. For resistance standardization to exist, the new terminology you would have far more trouble to understand the microelectronics and the standard terminology of the microelectronic. The neighbor adopted the several definitions which should become familiar with the definition presented in this section. Microelectronics. Microelectronics are the electronic technology associated with the electronic system built with the extremely small electronic part of the elements of the most today's computers, weapon system, navigation system, communication system, radar system, most made the extent of the microelectronic technology. All right, microcircuit. A microcircuit is not the old-time technician would have recognized as an electrical circuit. The old-timer would no longer achieve the familiar discrete with the individual resistor, capacitors, inductor, transistors, so forth. The microelectronic circuit, they discussed earlier, the complete circuit combined with on the substrate, they integrated with the process of fabricating microelectronic circuits. Essentially, one building discrete component of the character together, either into the substrate, single substrate, far different from the solid resistor, capacitor, the transistor, inductor, the other discrete components into the plate of the wires, and lugs the component of the character into the microcircuit referred to the elements rather than discrete components. The microcircuits have the number of these elements. The first substrate with the compare with the circuit with the discrete component of the same relative to the side of the man with the microelectronic circuit. They often thousands of the time of the number of the discrete component. The term high equivalent circuit doesn't say the description element to describe the partner relation. For example, suppose the circuit of the 1,000 discrete components amount within the chassis the 8 by 10 by 2 the inch of the equivalent circuit of the microelectronics might be built into a single substrate within 3/8 of the 1 and 1/4 inch. 1,000 elements of microcircuits would be very small, very close to each other higher density by comparison. The distance of the discrete compound with the amount within the large chunk of the elements within the substrate of the interconnect with the single substrate itself to perform the electronic function of the microcircuit that does not have the discrete component of the amount do is printed circuit board with the circuit core the assembly module component exclusive with the discrete component the microcircuit module. Alright, microcircuit modules may be with a combination component assemble the microcircuit with a combination microcircuit with a discrete conventional electronic component with a form one with a more distinct function for the microcircuit module. The module can actually the independently packaged replaceable with the example of the microcircuit the module with the print with the circuit board with the circuit card assembly figure 135 photograph of the typical microcircuit module. 135 says a microcircuit module. Miniature electronics. Miniature electronics include the miniature electronic component of the packaging. Some of the example of the printed circuit board, printed wire and board, the circuit card, and some of the modules pose exclusively the discrete electronic part of the component that exclude the microelectronic package amount on the board. An example of the assembly of the module. Motherboards are large printed circuit boards, but the plug-in modules and are considered miniature electronics. Cordwood modules all fall in the category of miniature motors, synchros, switches, relay timers, and so forth are classified as miniature electronics. Recall the microelectronic component with the containment of the integrated circuit with the miniature electronic containment the discrete elements of the part of the node for the printed circuit, the board with the circuit card with the assemblies are mentioned for the more than one definition. Then for the classic miniature of the unit most famous to determine the type of the components that be used. System package with the new electronic system of the development of the area of the planning requires special attention for the area of the grading or concern with the instrument of the system that performs properly. The designer must take into the account of the environmental factors may affect the system, include the temperature, humidity, vibration, electrical and defines fact with the greatest impact on you, but the technician the maintain level of the system the designer may take into account how well you've able to locate the problems, identify the faulty component, make the necessary repairs. If the system component cannot be maintained easily, then is not effective. The system packaging method of the enclosing mounting component of the primarily important with the maintainability. Levels of package for the benefit of the technician. System packaging usually broken down into 5 levels, 0 to 4. These levels are shown in Figure 136. Level 1, Level 0, Level 2, Level 3, Level 4. Alright, level 0 packaging identifies non-repairable parts such as the integrated transistor, resistor, so forth. Lowest level of which can perform the form is limited to similar replacing faulty element. Depending on the type of the repair might be a sample of the plug in the new relay of the fault repair with the integrated circuit, the special training and the equipment that may be regarded to the accomplishing of the repair. Discuss the topic 2. Level 1, the level normally associated with the small module, some module attached with the circuit that covers the motherboard's analog to digital converter or module device that converts with the signal with the function of the converting of the variable like a same way of the representative the number of the sequence of the digital form the analog to digital converter of the Figure 130 for the typical level 1 component at level of the maintenance relates to the faultability may be with a good one. The faultable mode of the module could be repaired at a later time to discover the concept of the signal reproduced if the equipment is inoperable. Figure 137 that shows the printed circuit board. Level 2, the level of the package component with the large and printed circuit board with the and/or cards, mother cards. Typical UV level is shown Figure 130 for the 138 with the card measure with the 115 inches by 5 and a quarter inch for the large dual inline pack with the 2 and a quarter inch by 3/4 of the inch for the dual inline pack with the printed circuit boards. Much lower interconnection is shown between the dual inline packages. It should also be able to locate a few discrete components of the repair consist of the removal of the dual inline package, the discrete component of the printed circuit board to play with the new part with the printed circuit board, play with the packet, and the remove the part with the level 0 or 1 part that would be handled described in those sections. In some cases, the printed circuit board should be replaced. Show the 138 of the printed circuit board. Here, level 3 drawers and pull out chassis. Level 3 unit that's shown for the 130 for the design accessible with the cave for the maintenance for the ease of the maintenance. Normally, circuit boards associated with the particular substrate for the group. Take the other with the draw. The nodes no only when they make for the orderly management. The subsystem limit is more many long wiring. Defective with the cards are removed with the stuff of the drawers. Defective with the components are repaired as described in level 2. Level 4 is the highest level of the pack, included with the cabinet's rack with the wiring with the harness the necessary interconnecting all the other level the other pack piece of the equipment of the scientifically classified on level 4 such as the radar antennas broken down level 0 to 3 with the same manner for the during component of the troubleshooting procedure the pack with the level 4 and level 2 level 3 to level 2 onto level 0 with identify the faulty component that is probably become more familiar with the system and you should be able to go right to the drawer and module causing problem. Interconnection printed circuit boards. Electrical systems become complex with the interconnection between the components that becomes more complex. The components that are added to give it the space of the requirement for the interconnection become extremely completed with the selection of conductive materials, insulated materials, the component of the physical side with the greater effect of the performance of the circuit, the port chassis with the material and contribute to the port circuit, signal with the circuit node with one of the circuit electrical interaction between the components. The three common method of the interconnection with conventional printed circuit board, the multi-layer printed circuit board, modular assembly. Each of these will discuss in the following section. Conventional printed circuit board with printed circuit board, but discovered that earlier in the topic one should be recalled that the printed circuit board consists of the glass epoxy insulating bait for the interconnection pattern with it has been edged the board made single with the double side, but depending on the number of the components mounted on it in the figure 137 to 138 eventual combined printed circuit board. Multi-labor printed circuit board. The multi-labor printed circuit board is emerging the solution for the interconnection problems associated with the higher density packaging. The multi-layer achieve the reduced weight converts space interconnecting circuit modules, limiting constant oscillating commodulated wiring harness, and provide shielding for the large number of the conductors. You provide uniform computer and conductor impedance for the high-speed switching systems. A lot greater wire and density of the board. Figure 139 show the individual boards mated with the form of the multi-unit layer. Although the multi-unit layer boards are similarly constructed various methods that the interconnecting circuit from layer to layer. The proof of the process the clearance hole with the place and then plated through the hole and layer build it up methods. Connection tabs. The dual-sided circuit board of glass epoxy base for the glass epoxy base multi-lever printed circuit board. Clearance hole method. Clearance hole method. The hole is drilled with the copper island with the terminating and the appropriate conductor with the top of the layer with the producer right. Discussed with the conductor second layer with the shown in the hole figure 140. The clearance of the hole is filled with the solder to complete the connection. If the hole is drilled with the entirely assembled, the connection side of the smaller hole is in the solder flow process. The U for the interconnection method. The conductor solid hole A, hole B with the conductors epoxy bolt and glass body. Conductors located several layers below the top of the connected step-down hole with the profit before assembly of the three-level board. The clearance hole of the drill with the first two, the B of the interconnect, the first level of the interconnect, the pre-drill with the hole is smaller than the drill within level 1 and 2. Succeeding layers to be connected the progressively smaller clearance holes. After this assembly, the succeeding ports of the conductors interconnected filling with the step-down hole soldering is shown in B of the figure 40 with the lower number of the interconnection required at the point of the larger diameter. The clearance of the hole of the top layer. The clearance on the top layers allows less of the space for the components packaging density. All right, your plated through hole method. Plated through hole method is an interconnection conductors illustrated in figure 141. For the first step of the temporary assembly with the layers and then into their final form, the hole corresponding with the required connection drilled through the entire assembly of the unit. Disassemble the inner wall of the holes interconnected are plated with which 1,000 inch thick. These effect the conductor of the board surface through the hole itself. The process is identical. You with the same printed circuit board. The boards are reassembled permanently bonded together with the heat and pressure. All the holes are plated through the metal. Printed conductors, power, printed wiring, board plated hole, epoxy for boarding. For bonding. Layer building up the method. The layer build up method of the conductors insulating layers that alternately deposit the backing of the materials. Figure 142. The method of the product for the copper ensure a connection between the layers to minimize the thermal expansion effect of the dissimilar materials. However, the reworking the interconnection build up materials are usually effective and it is not impossible. Alright, backing materials, plate conductors, deposit epoxy, window, plated connectors, window, deposit epoxies, replated plating process. Advantages and disadvantages of the printed circuit boards. Some of the advantages and disadvantages of the printed circuit boards we discussed earlier, and then the top of the strong lightweight, the eliminating point-to-point wiring, multi-layer printed circuit board with the component of the per cover, the entire circuit of the subsystem may be placed on the same cover. However, these covers have some drawback. For example, all of the components wire in some place repair the cars for the special training, other special equipment. Some of the cars cannot be economically repaired because of the complexity they are referred as to throwaways. Modular assembly non-repairable items approach the device that achieve the ultra-high density packet of the evaluation with the concept of the discretion component of the microelectronics, the progressive of the various state of the stages between the core wood assembly with the functional block that led to the complete subsystem single packet with the example of the configuration shown figure 143, view A and view B and view C. Printed circuit board is a discrete device with the cord wood, the metal mechanical support, the solder joint, the connecting rather toroidal inductors, and the thin or thick film elements, evolution of modular assembly, micro module. Alright, active elements of metallization, contactors, interconnection, external leads, integrated circuit. Your core wood module assembly shown for you with the figure 143 is designed with the fabricate the various forms of the side depending on the use upon the requirement. It's designed with the review to reduce the physical side of the increase the component density of the collection of the circuit. The discrete devices have the use of the technique somewhat limited with the available to discrete the components used. Micromodules, next generation assembly the micromodules design try to achieve the maximum density of the design with the discrete component of the thin film technology, insulator substrate, the principle method that use the construction technique allow for the efficiency use of space and also provide the maximal tape strength necessary to withstand the shock of the vibration. Semiconductor technology with improved further the integrated circuit with a flat back, integrated circuit form shown for UC with the emphasis of the density with the complexity that exists within the technology. The technology produced need of the reducing the side of the circuit all out with the reduction of the side of the circuit system, the advance of the large scaling integrated circuit is now available to very large-scale integrated circuits. They're being developed with the various integrated circuits manufactured. Continuation training toward the miniaturization will result in the system forms that will require the maintenance personnel, especially trained maintenance, the technique to perform testing involved in the isolation, repairing, complex miniature circuits. All right, environmental consideration. Environmental requirements of each of the system of the design with identified with the procurement, the specification, technical, environmental procedure requirements of the integrated circuit. Example shown in figure 1.1. After the system requirements have been established, components of the application packaging form of the considered with these thin leads are most effective and sufficient. Temperature and operating normal temperature with the humidity, shock, vibration, radio frequency interference. In the example of the table 1, the environmental requirements set forth the military standard to perform the actual standard of the particular failure of the bearers and to deceive to meet the standard of the equipment that can component that must perform the adequate with the test guideline for the example applies to the shock temperature component that is most with the shock of 200 to 500 G's versus the gravity of the during the vibration temperature component with 5 to 15 cycles per second over the 600 of the day of about 1/2 an hour, 60 to 25 seconds over the cycles for an hour, 26 to 33 seconds for a half hour. The radio frequency interference with the 30 to 40 gigahertz must not affect the performance of the component temperature, humidity of the factors is self-explanatory. When selecting most of the usable packable technique for the system, the designer must consider not only the environmental electrical performance requirements of the system, but maintain the aspect of the level of the system design with the interfere with the reflect the performance requirement of the maintenance and repair personnel. Your electric consideration. The electrical character of the components contained with adversely affected the display for the given the system, given the affects over the signal distortion, proper time, and the of the weakness frequency, the numerization of the other type of the unwanted error, the technique designed to minimize the effect of the system packaging component performance and incorporated with the system designed by the planners. Techniques should not be altered during the maintenance of the other techniques used the planners are discussed with the following sections: ground planes and shielding. Alright, a packaging level 1 and 2 with the copper plane will avoid with the feed with the required can be the plate anywhere with the multi-layer board. These plane with the tend to minimize the interference between the circuit for the external source. The other system levels are called crosstalk. One signal interfere with another. The radio frequency generation within the system. The external interference is suppressed through the use of various techniques. These techniques are shown in figure 144, showing the figure of the radio frequency shielding issue with the mating of the surface of the packaging cable to shield the heat sinks that are provided. Metal frame, the heat shielding, radio frequency shielding, cabling, radio frequency shielding, printed circuit board, the inner circuit device, the mounting holes, connection shield, input and output. Alright, interconnection and interconnection. To meet the high frequency character of the propagation time required for the present time of the future of the device package, they must have the acceptance distributed of the capacity of the induction of the type of the packaging, complement the design system, the integrated circuit of the microelectronic devices, be sure to leave the internal package of the bank, be careful to space the complex circuit, and circuit board to make the bank for the inherent speed of the integrated circuit of the keep the signal of the propagation time between circuits to a minimum, the signal delay with approximately 1 nanosecond per foot to reduce the distance between the circuit of such as the possible necessary for the requires use of the structure that high-density digital system and emphasize the large-scale integration of the system. Future all maintenance personnel should be especially concerned with the spacing of the circuit to leave the draft the surface clean with the factors that affect with the performance of the high-speed digital and analog circuits. Chapter 1 Summary.